Alright, so I'm going to go through the term 4 set 1 paper 2. Okay, let's start with the first question. So Timmy was paid $2 for every food delivery he made and an extra $5 for every 5 food deliveries made. So how much did Timmy earn if he had made 14 deliveries? Right? So 14 deliveries, each delivery is $2. So he will earn at least a basic amount of $28. Now for every 5 deliveries made, he will earn an extra $5. So for every 5, he will earn an extra $5. So he actually made 14 deliveries, so he will earn 2 times the bonus, so he will earn $10 extra. So total he will earn $28 plus another extra $10, so he will earn a total of $38. Question 1. Okay, question 2. 4 girls had to share the cost of a present equally. So there are 4 girls, right? When calculating the amount each girl had to pay, a mistake was made. The cost of the present was divided by 5 instead of 4. And each girl ended up paying $3.70 less than the correct amount. So ended up paying $3.70 less than the correct amount. The question is asking what is the cost of the present. So I have the cost of the present divided into 4, but instead of dividing into 4, it was divided into 5 equal parts. Okay, and because of that, each girl had to pay $3.70 lesser than the actual amount. Okay, $3.70 less than the actual amount. So if this is the actual amount for each girl, so this extra $3.70 must come from this extra portion, right? And so $3.70, $3.70, okay, times 4 would go into this extra portion, this 5th portion, right? So $3.70 times 5, $3.70 times 4 would be $14.80. That would be the portion for each of this wrong amount. Okay, so this is actually $14.80, right? So what is the cost of the present? I'll just have to take $14.80 multiplied by 5. That will be a total of $74. So the cost of the present is actually $74. Let's move on to question 3. So Marvin receives $60 for his pocket month every month, and the line graph shows the amount of pocket money he spent he saved each month from January to May. So let's look at the line graph and see how much did he save for each month. So for January, he saved a total of $15, February $12, March $25, April only $10, and for May $18. Now part A asks how much more money did Marvin spend in May than in February. So May was $18, February was $12, so he spent 18 minus 12, $6 more in he saved $6 more in May. In which month did Marvin spend the most amount of money? Now this graph shows the amount that is saved. So if you spend the most, you have saved the least. So which one is the month that shows the least amount that was saved? April, right? So for part B, the answer is April. So $6 for part A, April, the month of April in part B. Okay, question 4. The figure below is made up of a rectangle ABEF and a square BCDE. The total of the rectangle is 48 square centimeters and the area of the square is 16 square centimeters. The question is asking what is the total area of the shaded parts. Now, if I look at each of the shape here, now each of the shaded part is made up of two triangles, right? So in this case, I have this triangle. I'm just going to name this point O, for example, right? So the shaded area is made up of triangle AOF and area COD, triangle COD. Now this triangle share the same, if I'm going to draw, this is the height, it shares the same base as rectangle ABEF, right? So naturally, if the rectangle's area is 48 square centimeters, the area of triangle AOF, which shares the same, which shares one of the base shares one of the breadths of the rectangle, and the height extends all the way to the across the length of the rectangle, it will be half the area of the rectangle ABEF. Okay, this is actually what we have learned about finding areas of triangle. So the area of a triangle is half of the area of the corresponding rectangle. In this case, half of 48, that would be 24. Okay, so we have gotten one of the shaded areas. So now let's look at triangle COD. Now if you caught how I got the area of triangle AOF, you would have kind of inferred also, right, that the area of angle COD, triangle COD, which shares the one of the lengths or one of the sides of the base of the triangle, shares one of the length of the square, and the height of the triangle is actually sharing the length of the square as well. Okay, so the height of the triangle shares the length of the square. So again, if the area of this particular triangle COD would therefore be half of the area of this square BCDE, right? So half of 16, that will be 8 square centimeters. So now I can find the total area. So total area of the shaded parts will be 24 plus 8, that is 32 2 square centimeters. Now, the more observant of those among you, can we change the color of the pen to pink, I guess. Okay, some of you will realize, hey, actually what I can do, the shaded area is half of the combined area of ABEF, which is the rectangle, and the square BCDE. Right, because you realize that both triangles, they share the same breadths, or rather the breadths of the shape, the big rectangular shape, as well as the height. Right, so let me figure out if this is correct. Yeah, let's try. So half times base, combined area would be 48 and 16. Okay, so half of 48 plus 16 will be 64. Okay, so half of 64 is indeed 32 square centimeters, which is the same as what we did for the first method. So this is another way of getting the answer, right? Right, so the answer for 4 is 32 square centimeter. Right, now question 5. This is a true, false, not possible to tell question. Evaluate each statement. Okay, so let's look at the story here. Now I have Hazel, who took part in 3 maths competitions. And achieved different score for each competition. The average score of 36 competitions was 86. Okay, so this is the average score. Now her lowest score was more than 80. So one of them, the lowest score was more than 80. Now you're supposed to see whether each statement below is either true, false, or not possible to tell from the information given above, and you're supposed to tick the correct box. Now, statement A, Hazel's highest score was 90. Now it is possible, but is it definitely true? Or can you have enough information to tell that her highest score was 90? Now we don't know the highest score for the maths competition because it's not given, right? And her lowest score is more than 80. Now in this case, the highest score was 90. It could be true, it could be false. So in this case, we will say that it's not possible to tell. Right, statement B, Hazel scored 88 and 91 for 2 of the maths competitions. Now, is it a definite statement? Is it a true statement? In this case, not true, right? It could be, let's say, so if I have 3 competitions, her total score, average score is 86. Her total score would be 258. Okay, now her lowest score was more than 80. So in this case, more than 80, it could be 81, it could be 82, it could be 83. So in this case, if I take that the lowest score is 178. Sorry, her lowest score, why do I get 178? If her lowest score was 81, that means the total for the other 2 would be 177, right? So as long as the two other competitions, the total is 177, then this will be a true statement. Okay, now however, if I take 88 and 91, what will be the total? Okay, 179. Okay, 88 plus 91 is 179. I'm supposed to get 177 for the other two competitions, but I got 179 from this, so it's definitely false. Okay, it's not possible. So that's the answer for question 5. Okay, let's move on to the 3 marks question. Question 6. So Mr. Wong packed 315 pens into packets of 12. He sold each pack at $9.90 and the remaining pens at 95 cents each. How much money did he collect from selling all the pens? Right? So in this case, he packed them into packs of 12. So 315 divided by 12, you will get 26 with a remainder 3. Now if you're using a calculator, you realize that you will get something like this, right? Let me open up the calculator. Okay, so 315 divided by 12. Divided by 12. You have 26.25. What does 26.25 means? In this case, there are 26 holes and 0.25 of a set of 12. So there are at least 26. So 26 sets of 12, 26 sets of 12 would be 302. Now you have a total of 315 pens. So 315 minus 312, that is a remainder of 3. Right, so this is how I got my remainder. Okay. So in this case, each pack of pen is sold at $9.90. So 26 packs of 12, each pack is sold for $9.90, right? And the remaining pens, which is 3, is sold for 95 cents each. So if you key this in your calculator, you will get $260.25. So for questions, there are 3 marks and above, units is not given, you will have to put your own units. Question 7. There was an equal number of red and blue pens in a bookshop. Half of the red pens and 1/8 of the blue pens were sold. Okay, so let's look at each statement properly. So if I have an equal number of red and blue pens, I have red pens, I have blue pens, equal number. So when I draw a comparison model, both of the bars should be of the same length. Now half of the red pens were sold, so I cut it into 2 equal parts, and 1 out of the 2 were sold. Now 1/8 of the blue pens were sold, so now I have to cut it into 1 out. For the blue pens, I have to cut it to 8 equal parts. Now how would I cut it into 8 equal parts so that I can compare with the red pen model? Okay, the bar that the red pen bar. Okay, now if I first cut it into 2, so now I have, it looks the same, right? But how do I cut it into 8 parts? So I have 2. What number times 2 gives me 8? Okay, what number times 2 gives me 8? So I just take 8, divide by 2, that gives me 4. So I'm supposed to draw 4. 1, 2, 3, 4 parts. Another 4 parts. Then I have the total of 8. Now if I do this, if I were to cut the red bar into the same number of parts, 8 parts, I don't change the fraction. 4 out of 8 is still half. Okay, whereas in this case, number of blue pens sold is actually 1 out of 8 parts, right? So there were a total of 506 pens that were left. Now the unshaded parts, unshaded units are the pens that are left. So how many unshaded parts are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So a total of 11 parts was not sold. So 11 parts is 506. So one part is how many pens? 506 divided by 11, that is 46 pens. So they're asking you how many red pens were there at first. Now the number of red pens and blue pens are the same anyway, so you actually just need to count the number of units for either one of the colors, right? So there are a total of 8 parts for the red pen, so 46 times 8, that is a total of 368 pens. Okay, so that's 368. Question 8. A rectangular container measuring 28 cm by 15 cm by 22 cm, given a diagram, was 20% filled with water. Now, after some water was added into the container, it became 2/3 full. So how much water was added into the container? So by the fact they tell you that they added water, so 2/3 of the container must be more than the 20% of the container, right? And you're trying to find the difference. Okay, so let's do this the way that is easiest to explain. So at first, how much water is there inside? So 28 times 15 times 22. Now it says 20% filled, so I can immediately just multiply by 20%. Okay, I will get 1848 cubic centimeter. So finally, how much water was there inside? So 2/3 of the container, so I multiply by 2/3 of the capacity of the container, right? I should get 6160 cubic centimeter. So what is the difference? Difference, okay, will be 6160 minus 1848, 4312 cubic centimeters of water is added. Now they ask you to express your answers in liters. So this, I still need to change this into liters. So 4112 cubic centimeters is equals to 4312 ml. Okay, remember that 1 cubic centimeter is the same as 1 ml. So if I want to change to ml to liters, I divide by 1000. Okay, so I can change my decimal, I can shift my decimal point 1, 2, 3. Okay, so it becomes 4.312 liters. Okay, so 4.312 liters. That's the answer. Okay, important. Please read. Express your answer in liters. Okay. Okay, number 9. The table below shows the parking rates at the car park. So for the first hour, that's $2. Right? So for the first hour is $2. It's not $2 per hour. It's just when the car starts parking, okay, at the car park, as long as within the first hour, you'll be charged $2. So even if it's just 2 minutes, 1 minute, 10 minutes, 59 minutes, you will still be charged 2 hours. Now, after the first hour, next half an hour and part thereof. So a lot of you get confused what is part thereof. Part thereof just means they charge you based on a block of 30 minutes. So if you park there for 1 hour and 1 minute, you'll still be charged according to first hour plus another half hour. Okay, part thereof just means the whole block of 30 minutes. They'll charge you no matter if you if you park beyond the first hour. Alright, if you park beyond the first hour, anything beyond that will be charged in blocks of half an hour, right? So in this case, Mr. Lim parked his car from 2:35 p.m. all the way to 7 p.m. So how much did he pay? So let's do a timeline. Okay, so because the first one is half an hour, charged in first hour is charged in 1 hour block, so immediately I'll just do a 1 hour. So 3:35 p.m. So for that he have to pay $2 already. Okay, now then we start counting in half hour increments. Okay, so 30 minutes, so that will be 4:05 p.m. another 30 minutes, that will be 4:35 p.m. another 30 minutes, that will be 5:05 p.m. another 30 minutes, 5:35 p.m. another 30 minutes, 6:05 p.m. another 30 minutes, 6:35 p.m. Okay, my line is not long enough, I'm gonna extend it. Okay, now from 6, but he parked only until 7 p.m. right? So you may say, hey, 6:35 to 7 p.m. is only 25 minutes. Now, how much do you think he'll be charged for this 25 minutes? He'll still be charged, look at here, part thereof, so he'll still be charged $1.60 for this block. Okay, so let's count. So first hour is $2 plus how many blocks of 30 minutes? 1, 2, 3, 4, 5, 6, plus another part thereof, so 7 blocks of 30 minutes or half an hour, and each half an hour is charged $1.60. So if you key this in your calculator, you will get a total of $13.20. So Mr. Lim have to pay a total of $13.20. And please remember, for money, please put 2 decimal places. right? 2 decimal places. Even though your calculator may show 13.2, but please remember when you write in terms of money, when there are decimal points, it should be 2 decimal places, right? Number 10. ACDF is a rectangle where ABEF and BCDE are identical squares, right? Given that angle FCD is 65 degrees, they ask you to find angle BFC. Angle BFC is here. Okay, angle BFC is here. Now, these are squares, and if you can see that actually the lines drawn forms a triangle. So for such questions, there are always many ways of doing it. So I'm just showing one way of doing it. So in this case, I'm going to make use of this triangle CFD to help me. So I'm just going to draw CFD here. Hopefully I can draw a line C here, F, D. So I'm going to make use of this triangle here first to help me. Now these two are squares. This is a triangle inside a square, so this is a right angle triangle. Now, so if one of them is a right angle triangle and this is a right angle triangle, so to find this angle here, angle CFD, okay, I just have to do 90 minus 65 degrees, so this is 25 degrees. Alright, now if I want to find angle BFC, all I need to do is to take this angle here, minus 25 to get angle BFC. So how do I know what is angle BEF? Angle BFE. What is angle BFE? Now, FE is a diagonal line that cuts across the diagonals of two corners of a square. Okay, so naturally it divides this right angle here into two, so this is actually 45 degrees. So now with these two information, I can find angle BFC. So angle BFC is just 45 degrees minus 25 degrees. So the answer is 20 degrees. Now there are other ways of finding the angle, but I will not go through. I'll leave you as an exercise for you to try it out yourself. Alright, but for this question, the answer is 20 degrees. Okay, answer for question 10 is 20 degrees. Okay, question 11. Now Ella had some money. She spent $29 on a bag. Okay, $29 on a bag, and 2/5 of her remaining money on skirts. In the end, she had 1/3 of her money left. So a lot of fractions, a lot of you will panic when you see fractions, but don't worry, we will look at it part by part. Okay, so $29 on a bag. So I'm just going to draw a bar which represents $29 for the bag. Okay, and 2/5 of her remaining money. So she has some money. This is the remainder. And 2/5 of her remaining money. So that means I must cut the remainder into 5 equal parts. Okay, and 2/5 of it goes to the skirt. So this is for the skirt. Now in the end she had 1/3 of her money left. So in this case, this is the money left after spending on the bag and the skirt. Now how many units of money is left? Three units. Okay, and 3 units is what? 1/3 of the money. Okay, so if 1/3 of the money is left, so I'm going to switch to another color to help you see. So if this is 1/3, okay, where is the other 2/3? Here. This must be the other 2/3, right? This must be the other 2/3. So if 1/3 of the money left is 3 units, so 3 out of 3 or all of the money is actually 9 units. Okay, 9 units. So in this case, if you have, okay, I'm going to erase this for a while. So if you have 9 units altogether and you have 3 units of money left, okay, so total 9 units. Now amount of money left is 3 units. Now then the difference of 6 units must be the amount that was spent on the bag and the skirt, isn't it? Right? And 6 units is for the bag and the skirt. Now the skirt itself, is 2 units of money. Alright, so bag and skirt, okay, I'm just going to use B and S lah, huh? Okay, it'll be easier. B and S, the bag and the skirt is 6 units. Now the skirt is 2 units, so the bag is 4 units of money, right? So 4 units of money is actually $29, which is what she spent on the bag. Okay, so now you've established that 4 units of money is $29. 1 unit of money is just 29 divided by 4, which is $7.25. Right, so each unit of money is actually $7.25. Now part A asks for amount spent on the skirt. The skirt is 2 units. Okay, so $7.25 times 2, $14.50. So this is on the skirt. How much money did Ella have at first? We have established that there are a total of 9 units. Right? So 9 units of money is $65.25. So that's for part B. Okay. So part A, how much did she spend on the skirt? $14.50. How much money does she have at first? $65.25. That's the answer for for question 11. Question 12. Alright, Tommy had $32 in savings, made up of 10-cent coins, 20-cent coins, and 50-cent coins. Now, so some money is in 10-cent coins, some of the money is 20-cent coins, and some of the money is 50-cent coins. Now, we don't know how many of each coins does he have, but let's move on. But we know that if the total value of all these coins is $32. Okay, let's move on. So I'm just gonna have 10 cents, 10-cent coins, 20-cent coins, and 50-cent coins. Right? Now, he had 4 times as many 10-cent coins as 20-cent coins. 4 times as many 10-cent coins as 20-cent coins. So 4 times, so I'm just going to draw 4 units. 1, 2, 3, 4. Compared to 20-cent coins, 4 times as many. Okay, now then he had twice as many 50-cent coins as 20-cent coins. So if you compare 50-cent coins and 20-cent coins, he had twice as many 50-cent coins than 20-cent coins. So if 20 cents is 1 unit, 50 cents is 2 units. Now, the number of units that is drawn here in the model is actually the actual number of coins. Okay, so 4 units of coins are in 10-cent denominations, 1 unit of coins is in 20-cent denominations, and 2 units of coins is in 50-cent denomination. Now, the question only gave us in terms of the total value of the coins. So we need to do something what we call value times units to find the value of each denomination. So in this case, what is the value times unit of each denomination? So I have 4 units of coins, and these coins are 10-cent coins. So total, all the 10-cent coins, the value, total value will be 40 unit cents. Okay, 4 times 10 is 40, right? So 4 units times 10 cents is 40 unit cents. Now I have 1 unit of 20-cent coins. So what is the total value of all the 20-cent coins? 20 unit cents. Now, how about the 50 cents? If you guess, it is 2 times 50 is 100, so it's 100 unit cents. Now it seems a bit confusing. Don't worry, just think of it that 1 unit represents a certain number of coins. So if I have, like, let's say 10 in each unit, that means this is actually 4 times 10, 400 cents. Okay, but of course this is just an example. We don't know that how many coins are there in each unit. Okay, but we know that it's 40 units means 40 times the number of coins in each unit. So in this case, we do not know how many coins are there in each unit, so I just have to use units to make do for now. Okay, what would be the total value of all these coins in terms of unit cents? Okay, so 40 plus 20 plus 100 will be a total of 160 unit cents. Now 160 unit cents is equals to the amount of money, which is $32. Okay, so $32, because I'm using cents, so $32 is how many cents? 32 times 100, So it's actually 3,200 cents. So 160 unit cents is actually equals to 3,200 cents. Okay, so you can see here, this is cents, this is in cents. So 160 units is actually equals to 3,200. Okay, so 1 unit, 3,200 divided by 160. So each unit is actually 20 coins. Right? So there are actually 20 coins in each unit. So part A. What is the total value of the 50-cent coins? Okay, so there are a total of 4 units of 50-cent coins. So 20 times 4 means that he has, oh sorry, 50 cent is 2 units, not 4 units. Okay, I made a mistake here. Just let me erase this. So 2 units of coins, so it's 20 times 2. So he has 40 50-cent coins. Right? Each coin is 50 cents in value. So total of $20. Right? So he has $20 worth of 50-cent coins. Now part B, he wants to exchange his 10-cent coins for $2 notes. Right? How many $2 notes will he get? Will he receive? So let's find the value of the 10-cent coins first. So 4 units of 10-cent coins. So 20 times 4. That's 80 coins. Right? Total value of this 80 10-cent coins is actually just $8. Right? If you change $8 into $2 notes, you get 4 $2 notes. Okay, so that's the answer. So for part A, the answer is $20. For part B is 4. Question 13. So this shop, ABC shop, is having a promotion for chocolate bars. Buy 1 bar of chocolate at 10% discount. So 1 bar, you get 10% discount. But if you buy 2 bars, you get a 20% discount. And what is the usual price of each bar? $3.50. Right? Now let's look at here. Joey, he bought 1 bar. So how much did she have to pay? 1 bar is only 10% discount. So the discount is 10% of $3.50, which is actually just 35 cents. Now, discount is the amount you don't have to pay. So the price that she paid, you take the usual price minus the discount, and she only had to pay $3.15. Okay, so this is after the discount. Now, Kelvin, on the other hand, has $25, and you want to find out the maximum number of bars of chocolate he can buy. Right? So, of course, if you buy 2 bars, you pay less, because later you'll work out. You realize that 20% discount is actually more than 10% discount, definitely, and you buy 2 bars at a time, it's actually cheaper. So let's calculate. If normally for 2 bars of chocolate you will have to pay a total of $7, right? But the discount for 2 bars of chocolate is 20% off the usual price of $7. So you pay $1.40 less. Right, so price paid for 2 bars of chocolate is actually only $5.60. Okay, so you realize that actually you buy 1 bar is $3.15, but 2 bars is $5.60, which is less than even you'll be less than the price you pay for 1 bar of chocolate at a discount, right? So in this case, Kelvin has $25. Now, how many sets of 2 bars can he buy? So I divide it by $5.60. I will get 4.46 something on the calculator, right? So this means that he can buy a maximum of 4 sets. Okay, 4 point something, right? So 4 sets of 2 chocolate bars. Okay, because it's 4 sets, 4 point something sets. Okay, it cannot buy a 5th set, so it can buy only a maximum of 4 sets with $25. Now, what is the remaining amount that he have? So he has $25. Then if he can buy a maximum of 4 sets, and each set is only $5.60, you realize you will only have $2.60 left. Not enough to buy another bar, even if it is at a discount. Okay, even at the discount, you need at least $3.15, but you only have $2.60 left, so not enough to buy another bar, right? So maximum of 4 sets, each set is 2 bars, so total he can buy 8 bars with $25. Okay. So for part A, 1 bar after discount is $3.15, and for $25 he can buy a total of 8 bars maximum, right? Now bars is optional, so I'm just going to remove this, just erase this. The answer will be 8. Question 14. Now the area below shows a rectangular piece of paper with 2 folded corners, A and B. Okay, so that means this corner is folded down and this corner is folded down. Okay, right. The area of the resulting shape form X and Y, it is as such. The area of Y is 1/4 the area of X. Okay, so what does this actually mean? So if you look at the diagram, triangle Y is smaller than triangle X. How much smaller? 1/4 the size of X. So in other words, I can say x is 4 times the size of y. Okay, so x is 4 times the size of y. This is another way of interpreting it. Okay. Find the ratio of x to y to the area of the rectangle piece of paper before it was folded. Right? So we need to find the area of x, y, and the area of the piece of paper before it was folded, and then construct the ratio. Okay, so let's do it one at a time. Okay, so if we look at x, it shows here 12 centimeter. This line is 12. This length is 12 centimeter. This length, how do I know what this length is? Now, it's not important because you know that this is the corner of the paper folded down. So when you fold it down, this is the point A that's being folded down, right? So if this is, it shows here this 18. Actually, this line here is the same as this line here, which means this is 18 centimeter, right? And this line here is actually this line here. Okay, which means that this is 12 centimeter. All right, so area of area of x, area of triangle x is half of the base. In this case, I'll take 12 as the base times the height, because you see there's a right angle here, so 12 and 18, these two sides are perpendicular to each other, so I can use them as base and height. So half times 12 times 18, I will get 108 square centimeter. That is the area of triangle x. And it says that the area of y is 1/4 the size of x. So area of triangle y is 1/4 the size of triangle x. Okay, so that is 27 square centimeters. Now, then the area of the rectangular piece of paper before it was folded, so area of the paper 42 is the length, then the breadth will be 12 plus 9, so 42 times 12 plus 9, and that will be 882 square centimeters. So now I can start constructing the ratio. Okay, the ratio that is required from the question is the area of x to the area of y to the area of the paper. Okay, so area of x is 108, area of y is 27, and the area of the paper is 882. Now, the final answer, you're supposed to simplify this ratio. You realize that these three numbers, they have a common factor of 9. So all these three numbers can be divided by 9. I will have 12 is to 3 is to 98. This will be the final answer. to 3 is 2, sorry, not 48, 98. Right? Question 15. In the figure below, JKLM is a square. So JKLM is a square, right? So square means it has 4 equal sides. So I'm just going to use a hash mark to indicate that. Now it says that additional information, these two triangles are equilateral. Okay, we call equilateral. Equilateral means they have 3 equal sides, and the 3 angles inside the equilateral triangle would be 60 degrees. Right? So where is J, L, H? So J, L, H is equilateral. Okay, so I'm just going to use, maybe I use a different color to indicate that they are equilateral, right? As well as L, M, G is also equilateral, right? But you see here that one of the sides of this equilateral triangle share the same side as a square. So one hash mark, I can put these two will also be of the same length as this, right? And I will start indicating, I will not confuse you, but we will start trying to solve the we'll start solving the angles. They ask you to find angle HLG. So HLG is here. Okay, this is the angle they want you to find. Right? Now, to find this angle, there are a few ways. I can make use of the equilateral triangle LMG, right? So we know that this will be 60 degrees, right? We also know that some other things that we know is that this, being an equilateral triangle, would also be 60 degrees, right? So if I know this angle here, okay, maybe I shouldn't color it. Okay, if I know this angle here, and what would be this angle here? This is actually, you can see that it is half. This is diagonal across a square, so this is actually 45 degrees, right? So now I know if this is 45 degrees, I can find this angle here. So the first step would be to find angle M, L, H. So MLF rather. Okay, this angle here. Okay, this angle here. Okay, this angle here. So MLF is just 60 degrees minus 45 degrees. That's 15. So this is 15 degrees. So if I know that this is 15, I can find angle HLG is just 60 degrees minus 15. That's 45 degrees. Okay, so this is 45 degrees. Part B, find the sum of angles FHG and angle HGF. Okay, so FHG is this one and HGF is this one, right? So how do I find the sum of these two angles? What I'm going to do is to make use of this triangle LHG to help me. Right, so if I know that one of the angles in this triangle is 45, that means I can find the other two angles, right, or rather the sum of the other two angles. In this case, LHG and HGL, right? But I also know that this angle here is inside the equilateral triangle LHM. So this would be 60 degrees. Right? So if I make use of triangle LHG, right? Angle FHG is actually FHG. Oops, the angle FHG okay, so by using triangle LHG, angles LGH plus angle GHL, it is actually 180 degrees minus 45, which is 135 degrees. Basically, I'm finding the sum of this angle here and this angle here. Alright, so but these two angles, the sum of these two angles include the 60 degrees here, so I have to take away 60 degrees. 135 minus 60, there is 75, and this is exactly what we want to find. This will be the leftover. Okay, basically I take away this angle here, right? So the answer is 75 degrees. Okay, for part A it's 45 degrees. And there are other ways of doing it. Okay, I'm maybe something less complicated, but yeah, this is just one solution, right? So first, part A, finding angle HLG, the answer is 45 degrees. Okay, and finding the sum of angle FHG and angle HGF is 75 degrees. Alright, question 16. So I'm going to change this to Mrs. Okay, so Mrs. Sue spent $381 on chocolate and butter cookies. Each box of chocolate cookies costs $11 and each box of butter cookies $12. Right, so she spent a total of $381 on two types of cookies. Each box of chocolate cookies is $11 and each box of butter cookies is $12. Now the chocolate cookies were packed in boxes of 24 cookies each, and the butter cookies were packed in boxes of 20 cookies each. Right, now she bought an equal number of chocolate and butter cookies, right, and she in total bought less than 800. You can do guess and check, but I'm going to show you or rather you can do systematic listing, but I'm going to show you a different method, right? So in this case, First question, how many boxes of chocolate cookies did she buy? Now in this case, she bought an equal number of chocolate and butter cookies. The problem is the chocolate cookies come in boxes of 24, while the butter cookies come in boxes of 20. So it is not that she bought an equal number of boxes, no, she bought equal number of cookies. So I've got to find a common multiple of 24 and 20, right? What is the first common multiple of 24 and 20? So 24 times 1 is 24, 24 times 2 is 48, 24 times 3 is 72, 24 times 4 is 100 and so 96. Okay, and 24 times 5 is 120. Okay, how about multiple of 20? So multiple of 20 is 20 times 2 is 40, 60, 20 times 4 is 80, 20 times 5 is 100, 20 times 6 is 120. So why do I want to find the first common multiple? It means that every time she buys, because she bought an equal number of chocolate and butter cookies, means that she has to buy in sets of 120 chocolate cookies and 120 butter cookies at the same time. And that will be 5 boxes of chocolate and 6 boxes of butters. So it all means that she has to buy in sets of 5 boxes of chocolate cookies and 6 boxes of butter cookies. Okay, so that means you have to buy 5 boxes of every 5 boxes of chocolate cookies, you have to buy 6 boxes of butter cookies, so as to get the equal number of chocolate and butter cookies at the same time. Okay, so now we know that she has to buy in this sets, right? So 5 boxes of chocolate cookies, each box is $11. That will be $55 for the chocolate cookies, and 6 boxes of butter cookies, each box is $12, so $72 for the butter cookies, right? So this is one set. So one set of cookies is $127. Now she spent a total of $318, right? So $381. Okay, divided by $127 per set means she bought a total of 3 sets, which consists of 5 boxes of chocolate cookies and 6 boxes of butter cookies, right? So in this case, part A, how many boxes of chocolate cookies did she buy? She bought 3 sets. Each set there's 5 chocolate cookies, so 15 boxes for chocolate cookies. Alright. Now part B, how much money did she spend on the butter cookies? So how many boxes of butter cookies did she buy? 3 sets. Each set is 6 butter cookies, 6 boxes of butter cookies, so total of 18 boxes of butter cookies, right? And each box of butter cookies $12. She bought a total of 18 boxes, so altogether she spent $216 for the butter cookies, right? So part A, how many boxes of chocolate cookies did she buy? She bought 15, right? How much did she spend on the butter cookies? $216. Okay. Question 17. In this figure, you have a big square ABCD, and they tell you three of the lines AD, AE, and AB are equal in length, right? So that makes two isosceles triangles. Okay, there are two isosceles triangles, A, E, D. That's one of them. Okay, and the other one will be A, E, B. So there are two isosceles triangles here, right? And given the two angles, angle BCE is 63 degrees and angle BFE is 105 degrees, ask you to find angle BDE. BDE is here, okay, and the other angle is here. All right, so let's try the first one. Now in this case, I'm going to make use of a few properties, all right, of angles. So in this case, I'm going to mark out some angles that I already know without calculating. So one of them will be this angle here, 105 degrees, because of vertically opposite angles. And another angle that I know will be here, 45 degrees, right? Because this is the line BD just cuts across the square. So 90 divided by 2, 45 degrees, right? So this is also 45 degrees, right? But this this is for us to know for now. So the first angle BDE, I'm going to use a strategy. Okay, I'm going to make use of this isosceles triangle here to help me. Right, let me draw the isosceles triangle properly. I'm going to make use of this isosceles triangle to help me. Now if I know this angle here, right, then I can know this angle, right? And angle BDE would just be this big angle minus 45, right? So my first job here is to find this angle here, right? I'm just going to erase the unnecessary marks first. So how do I find this angle here? Now this angle here is inside another triangle, AFD, right? So angles of a triangle would be 180 degrees. So to find this angle here, angle DAE would just be 180 degrees minus 105 degrees minus 45 degrees, and that will be 30 degrees. So this is 30 degrees. So now I know that this is 30 degrees. I can make use of the isosceles triangle. Sorry, not the first one is not using ADE. It's supposed to be using ADF. Okay, so this now I'm using ADE, the isosceles triangle, the green one, right? So I can find this angle here. Angle ADE would just be 180 degrees minus 30 degrees divided by 2. So that would be 75 degrees. So this is 75 degrees. So from there, I know that angle BDE would just be a matter of taking 75 minus 45, and that will be 30 degrees. So I know that this is 30 degrees. Okay. Alright, now, so we have solved part A. Now, how about part B? I'm going to erase all the unnecessary lines first. I'm going to erase this, I'm going to erase this, I'm going to erase this, I'm going to erase this. Right. So, now that to find this angle BEC, this one, right, my strategy will be to make use of this triangle here, BCE, right? So once, if I know this angle here, I can make use of, again, angles in a triangle, right? So to find this angle here, I can make it, okay, this is not necessary actually, so I'm going to erase this. If I know this angle here, I just have to take 90 minus this angle here to get this, right? So how do I find this angle here? I can make use of the isosceles triangle, this isosceles triangle, right? So how, if I know this angle here, I can find this angle here. Okay. So how do I find this angle here? How do I find angle EAB? Okay, actually it's very simple. This is actually 90 degrees, right? And here is an angle DAE is already 30 degrees, so I just take 90 minus 30, so that's 60 degrees. So this is 60 degrees here. I found this as 60 degrees. So then I make use of the isosceles triangle ABE to find angle ABE, right? 180 degrees minus 60 degrees divided by 2, that will be 60 degrees, right? So this is now 60 as well. Actually, you realize that the green triangle is an equilateral triangle, but never mind. It's a property that we're not going to use for this question anyway, right? So now I know that ABE is 60 degrees. I can go ahead and find angle EBC. Angle EBC would therefore be 90 minus 60, and it will be 30 degrees. So this is 30 degrees. So finally, I can make use of triangle BEC to find angle BEC. 180 minus 30 degrees minus 63 degrees, that would be 87 degrees, right? So I found the two angles that I need. So part A, 30 degrees, part B, 87 degrees.